Good afternoon, everybody. How are you doing today? I hope you're enjoying the conference so far, and you like the keynotes. I assume you all attended. My name is Alexander Nosov, and I'm program manager at Microsoft. My responsibility is building business continuity solution in the SQL database service in Windows Azure. If you think about the most important job of your average CIO, it really boils down to making sure that their business applications are not impacted by various planned and unplanned events. And achieving business continuity has never been easy. The comprehensive solution involves various levels of redundancy and usually is pretty expensive for on-premise deployments. In fact, only very well-funded and sophisticated IT departments were able to build and afford true business continuity for their applications at a very high price point. Now, with the adoption of the cloud technologies, we have a great opportunity to democratize it. And if we do our job right, what used to be a privilege of the few will become affordable for the masses. So in this talk, we will discuss how you can leverage the existing capabilities in Windows Azure to enable business continuity for your applications. Now, you may be wondering, what is this number down below? Here's the deal. I will have a Q&A session at the end. And when we have time to discuss and answer questions. But I also understand that you might like to ask questions in the context of individual slides. So this is my cell phone number. If you'd like to text me your question, I promise I will read it and answer, if I can, at the end. So again, thank you very much for attending this session. I realize that you had a large selection of options, and I really appreciate you coming by. Now, before we start, I'd like to set expectations. I actually have just 3 goals for this session. I want to talk about the scope of the problem. I want to explain how you address different scenarios using the capabilities of Windows Azure. And I will briefly talk about the future directions of business continuity. Now, I won't be discussing the application designs. I won't be showing any code samples. And I won't be talking about migration to cloud or hybrid solutions. So if this is not what you expect, I would recommend considering a different session. But hopefully, this is what you come for. Now, there is a wide range of different failures that could impact your application availability. I like to categorize those failures into the 3 classes. Number 1 is what I call local failures. This is about failing servers, failing media, corruptions, network devices. Second type of problem is unwanted modifications of your data by application or operator or user, basically human errors. And finally, we have what I call widespread loss of facility, which typically is caused by natural disasters, but often also a result of some tragic, catastrophic human error. Now, each of those problems will impact your application availability, but addressing them require different solutions. And I will take each of them and I will show how the capabilities of Windows Azure will enable your application to not be impacted by those failures, or at least to minimize the impact of those failures. Now, before we continue, I'd like to talk about fundamentals. There are building blocks which allow us to enable business continuity. And number one, physical security. Microsoft has state-of-the-art data centers with climate control, fire prevention, redundant power. In addition, it has state-of-the-art security procedures of personnel. Number two, platform security. This is about service isolation over virtualized compute and network. It involves clear trust boundaries, multiple lines of defenses. Next is geodistribution. We have data centers in various geographies across the globe, and each has the same exact set of services. In addition, storage is replicated locally and remotely to allow the data to recover geographically. And finally, compliance. We all understand how important it is for you to know that the platform which hosts your data meets the security standards. And therefore, industry certification is a core part of Windows Azure roadmap. Now, these fundamental blocks are core prerequisites for business continuity. At the same time, it's a great illustration why this solution is so complex and expensive. Now, there is no magic. It is just as expensive for Microsoft as it is for anyone who is attempting to build redundancy. The reason it can be made affordable is because we can share the same fundamental infrastructure among thousands of users. Now, quickly about some terminology I'm going to use in the course of this talk. First of all, these two terms that are widely used in definition of the SLA. First stands for recovery time objective. It's a basic measure of time, maximum time, which is required to recover availability of an application. Recovery point objective stands for essentially maximum data loss. It is also measured in time, and for example, if RPO is defined as 1 hour, it means last 1 hour of changes to data before an unplanned event occurred might be lost. Second couple of terms is home region and backup region. This is specific to Windows Azure. When we basically allow you to subscribe to services, you will choose a region. That choice is usually driven by your business requirements. You want to have your application close to your clients, you pick a specific region. Now, home region is where your application runs normally before any failure occurs. Backup region is where a redundant copy of data and the application is hosted. And if a major failure occurs, you will have to sort of activate that redundant copy, which is called failover. Failover is the process of moving active application from the home region to the backup region. And finally, failback is the process of coming back to home, so to speak, when the home region is recovered after investigation and fixing the problem or what have you. You might want to bring your application back because that's why you wanted to run in the home region in the first place. That's called failback. That's the terminology slide. Now let's move to the first scenario. Remember, the first scenario was the local failures, when servers fail, or local network fails, or network devices fail, or perhaps some corruption took place. Now, first observation is those failures are inevitable. We are using commodity hardware, thousands and thousands of servers in data centers, and essentially, they fail. We all know that. There's nothing we can do about it in terms of not failing. Now, in addition to that, people make operational mistakes. It takes only one wrong configuration file to essentially bring down a lot of resources. And finally, even though each of those failures is very infrequent, at cloud scale, those infrequent failures actually happen every day. Which brings us to the conclusion that we need an automated solution, fault tolerance solution, because we cannot expect an average application to be reacting to those daily failures and doing something to recover from. That's why in SQL database servers, we built the solution for this as an automated process. And I'm going to describe that process. So essentially, each database, when you create it, it's a logical database. It's an endpoint, essentially a gateway to your data. When you call or initiate a transaction, what happens actually, it gets routed to physical hardware and real databases on those servers. Each database has 3 replicas. One is primary and 2 secondary. So you have local redundancy to make sure that you can essentially handle those failures, and it does not impact your availability. Now, when the application commits the transaction, what happens is we make sure that that commit is acknowledged by at least 1 out of 2 secondaries, which means you always have at least 2 copies of your database in sync and guaranteed to have the latest data. And the 3rd copy eventually sort of catches up. So essentially what we do is reads are executed on the primary right away, but writes are replicated, and we wait for acknowledgement at least from 1 out of the 2 secondaries before we return the transaction to the client. In addition, each of those replicas is backed up on the attached storage device on every server. So you have 3 copies and 3 backups. That's the redundancy solution locally. Now, let's just kind of open the hood here and look into a little bit of the internal operation of this system. So the servers in the cluster, they form a ring. They all connected together, and neighbors watch the state of health of their neighbors. So essentially, every server kind of monitors the 2 neighbors in the ring. There is this centralized process called partition manager, which essentially monitors the state of the cluster and has the information about where each individual database is located. Because of the criticality of this service, its level of redundancy is even higher. It's also a database, but it has 7 redundant replicas as opposed to 3 which the individual databases have. That is because if that service is down, it basically destroys the operation of the entire cluster. Therefore, we cannot afford any level of risk here. So that is a highly, highly available service in the cluster. Now, when you create a database, the 3 replicas are placed in different servers, in fact, even in different racks. And this is to ensure that you are not impacted by the failure, for example, of entire rack. So even if entire rack is failed, you will not lose more than one replica because they never are placed within the same, what we call fault domain. So essentially, different databases are placed according to this scheme to make sure that they never fail together. Now imagine that one of those servers now fails. Now we had 3 databases placed onto this server. One of them was primary and 2 secondaries. First of all, like I said, the neighbor detects that the server had failed and reports to partition manager. The first thing the partition manager does, it basically checks, okay, what have I lost? What are the databases that were on that server? And it issues the command to essentially, because there was one primary that was lost. Now, the secondary to that primary needs to be promoted. So it issues the command, the secondary becomes primary, but it now is missing one of the secondaries. The next command is essentially say, hey, let's rebuild the lost capacity, lost replicas. And because we lost the server, the missing replicas are being rebuilt on different servers where the capacity is available. So the partition manager not only knows where the databases are, it knows where there's spare capacity to be building those missing replicas. So that process essentially concludes with the primaries now knowing where the new replicas are, and essentially everything sort of comes back to a healthy state. Now, before we rebuild the replica, we also allow some time in case the server might recover, so that we avoid unnecessary basically recreation of the databases, because it takes time. It's a timely process. And it takes resources. So we kind of wait for an hour before we conclude, okay, it's a failure, let's rebuild the whole thing. So this is a solution of how the redundancy and failover works automatically for in case of a local fail, to be able to essentially tolerate the local failures. And there are a few critical capabilities that have been implemented here, and they're also critical in understanding of the future extensions of those capabilities. First of all, the system is capable of creating new replica, which means it knows how to take one database and produce an exact transactionally consistent copy of it. Second, after that is done, the system is able to synchronize data. So when you commit a transaction on the primary, the transaction is synchronized immediately on the secondary. It knows how to stay consistent. So what happens is, in any point in time, those replicas are always transactionally consistent. It knows how to detect failures. Essentially, we have watchdogs that basically check for known problems, connectivity problems, corruption problems, etc. And finally, the system knows how to fail or how to initiate that transition from secondary to primary in order to be able to continue servicing the requests from the application. So how do you benefit from it? Well, quite a bit, actually. First of all, you don't have to worry about any of this. There's no additional cost administering local failures and local failovers. Secondary, like I said, the asset properties are maintained by the system. You can basically count on the fact that no matter what happens, no matter how many failovers we execute, the databases are always transactionally consistent. The process is automated. And we also do the dynamic routing. For example, if we promoted a different replica to the primary status, now the traffic from the application has to now go to that new primary. So we take care of that process. We fail over not only the databases we also fail over the connections. Now, the caveat here is that there is a short downtime during that process, so your application needs to have the retry logic. You need to be prepared to the fact that you may see some failure of a transaction and you need to retry. And that's about it. That's the only thing that you need to actually do to participate in this process. So we don't charge for that redundancy, even though we spend capacity, storage, compute resources, etc. We don't charge. It's all sort of built into the base price of the service. Now, the RPO in this case is 0 because, remember, I said we guarantee that every change is committed to at least 2 out of 3 databases before we return success, which means whatever happens, there is no loss of data. But the RTO is 30 seconds. That downtime could be up to 30 seconds when you basically will have to retry your transactions. In addition, we have a formal SLA, which now currently defined as 3 nines, and it amounts to 40 minutes of downtime per month, which means those 30 seconds, potential 30 seconds periods could be up to 40 minutes per month within the SLA. That's our formal commitment to our users. So that's the solution. I'll give you a few seconds if you want to type a question before we move on. They're guaranteed to be in different fault domains, yes. And by the way, not only fault domain is not only the domain of failures, but we also use the same solution when we do the upgrades, when we do rolling upgrades of the service itself, which obviously impacts the availability. We define so-called upgrade domains, and we make sure that the different replicas are placed in different upgrade domains as well, so that when we, for example, re-image machines within the upgrade domain, we don't impact more than one copy of any database in that domain. All right, let's talk about the human errors. So we know that we make mistakes. That happens. There's nothing we can do about it. We just need to be prepared. The other thing is we cannot detect those errors. They're completely legitimate operations usually. You have administrative rights, you drop a table, you destroy a database. From the system perspective, it's completely normal. There's nothing we can do about it in terms of proactive detection of such failures. Which means we have to involve a human into the recovery process. The human has to decide, has to recognize the error, and has to do something to recover from it. Only the human knows when the error took place. Unless, of course, you build some additional sophisticated logic into your application that knows, okay, well, if certain tables disappear, that means that the application has to do something. But essentially, it's a reflection of the human action. So the typical solution, I'm sure aware, we need to have a way to go back to the previous application state. That's the solution from human error. Now, what we can do about it is, again, remember I told you about the basic capabilities that we implemented as part of the local failure solution. One of them was the ability to create a replica database. So we do it automatically. But what we can also do is to expose it as an external feature and give an interface so that you can say, create a database for me that is transactionally consistent. That is exactly what we have done. there is an operation called, we can call it dbcopy, but it's a T-SQL command that allows you to say, please copy a database from this one to the other one. And as copy takes place, we also create automatically the 2 redundant replica for each, because it will become a normal database after the copy is completed. So what it allows you to do is essentially to create these copies as you wish. And each copy is transactionally consistent and reflects the state of database at the moment of completion of that process. So what it does, essentially it extends, as I said, the replica creation and exposes to the user. The database is consistent after completion. And what's important is that because of the size, the copy may take time, but during that time, you are free to continue to update your source database. Let's say your copy takes an hour. During that hour, there's no downtime. You continue to execute transactions on the primary or on the source. And when we are about to terminate and create that secondary database, we essentially take all these transactions and replicate them before the database is created, which means your copy will be consistent as of the end of this process, not as of the beginning, but as of the end. And there is no downtime. So you can copy to any servers, but in the same region. That's a limitation. You cannot copy to a different region, but you can copy to the same region. So essentially, you can create as many copies locally as you wish. And as I said, you copy from the live database. You don't have to stop your work. You don't have to block the transactions, any such thing. You can continue doing that, and in the meantime, we will copy the database for you. And of course, if you recognize that, oh, this is the wrong database, or for whatever reason you need to cancel it, you can cancel at any time. You can monitor status. You can see how far we are in the process. In percents, we can show you that process, progress of copy. And finally, we only bill you if the copy is successful. If you fail or you cancel, there is no charge. But the charge is prorated day use. So if you created a copy, it'll be prorated day use of the database. So let's basically examine how the process looks. Let's imagine you have in the West Europe region, this is your home region. Remember the terminology. This is your home region. And you have an application that uses a database called dbmain. So the admin, the administrator, who is basically responsible for business continuity, has a process that presumably automatically, not necessarily a human process, but some script that creates those copies periodically. Because the copy might take time, again, depending on the size of the database, you can decide how often you do it. Usually people do it, let's say, daily. So you create these copies every day, and you keep as many copies as you believe you need in order to recover. Because sometimes the human errors are detected late. It could be that your unwanted modification is detected, let's say, a few days after it took place. Because you started, I don't know, launched a report and you see something is missing. You have to go back perhaps a few days to a previous state a few days back. So it is your decision how many of these copies you want to keep. And of course, it's a balance, of course, the cost benefits, so to speak, because each of those databases will cost you money. Now, if you made a mistake, like I said, obviously your database is not good anymore. Your application cannot operate. You have to decide how far back you want to go. You pick the right one. And the way to sort of reroute the application is a simple rename. What you do is you change the name of the old database, the one that you were using, and that was corrupted essentially by human error, and you change the name. I would recommend that you allow some time, because it's a process. Changing the name takes some internal, it's an internal workflow, so you may want to inject a pause before you rename the previous version of the database. And after you've renamed it, the application will automatically reconnect to it and continue on. As I mentioned, this is the charge we will add to your bill. One thing that it does, it copies the entire database. It's not an incremental backup. It's essentially a snapshot of your database. You are responsible for the cleanup and retention. Like I said, you have to decide how many of those copies you want to keep. And as they expire, you need to clean them up, because we will continue billing you for those databases. Now, database federation are not yet supported, but it's in the works and it will be supported soon. Now, let's discuss RTO. In this case, the time that it'll take to essentially recover your application is the time to recognize the error and time to rename the database. It's actually quite quick, because those effectively are standby databases. They're ready to be used. And it's just basically renaming is what it takes to make them active. Now, it's of course always about how much you're willing to spend to maintain that pool of previous versions, and for the period of time that you need based on your policies and processes. So one option to consider, instead of copying the database and keeping it as a database, is to create essentially a package of the database and put it, the backup package, and put it in the blob storage. Blob storage is much less expensive than the live database. So what you do in this case, you create a copy, you put it in the storage in the format we call backpack. And you do that, and then you delete the database because you don't need it anymore. And you do this as many times as every day, presumably, for example, and you keep those copies in the storage. When and if an error occurs, then you will have to decide how far you want to go, which particular specific backpack you want to use, and then restore. So what it does, it leverages a service called import-export. It's a service that we have released quite recently, and I will talk about this more in details during the demo. Now, it reduces the cost, because like I said, it's 14 cents per gigabyte of storage versus, depending on the size of database, the cost of a daily cost of the database. So it is the trade-off. But the flip side of it is it's a little bit more expensive, a little bit more complex in terms of the process. You will have to not only create a copy of the database, you'll have to export it into the blob, then you have to delete the database, etc. So it's a little bit complex in that sense. But more importantly, it takes longer to recover. So if, for example, you recognize an error immediately and you need to bring your application back to the healthy state, in addition to the other parameters, there is this time to import the database. So you will have to, before you can rename it, you will have to import the database from the backpack. And again, this process takes as long as the database size is. It depends on the size. So this is a trade-off between the cost and essentially RTO. Again, feel free to text me if you have any questions. Few seconds for you. Okay. Let's move to the disasters. Interesting thing about those is they actually happen much more often than we tend to think, much more often than, for example, earthquakes or tsunamis or meteorite strikes or whatever. And the reason for that is it's more likely to be a result of some catastrophic human error than a natural disaster. If you think about, let's pick an example, Chernobyl disaster. It was essentially a set of incomprehensible related human errors, just a sort of sequence of steps that normally would and should not ever happen. And they all resulted in a tragic event that caused tremendous pain and suffering of thousands and thousands of people. That wasn't a disaster that is natural by any stretch of imagination. It was all about human errors. Now, the solutions for the widespread loss usually involves redundancy, geographic redundancy in a remote location with high latency of data transport. And the recovery usually results in data loss. It's just kind of, it's basically the laws of physics. So what we need is, like I said, geographic redundancy and the ability to fail over to that redundant copy that is somewhere else, far away, hundreds of kilometers away. So what can be done in today's world of Windows Azure? Well, let's consider how this would work. Let's say your home region is West Europe, and you use the North Europe as the backup region for your database. So you have the application, the end user, presumably somebody with a browser, connects to Azure DNS, gets the URL, hits the application. It in turn connects to the database, and everything's sort of great. And then in the meantime, application admin does what we described, the process of creating the database copy for the purposes of protection. And then every time the copy is created, it puts it into this remote blob. So essentially the blob, the backpack of the database, will be stored in North Europe. We allow to export into any region that you would like from the database. Now I want to briefly talk about why in this case we need to make a copy. Why can't we just create a backpack from the live database? The reason for that is because this process requires that database is not being updated during the backup, during the export process. The export does not support sort of transactionally consistent result, doesn't guarantee transactionally consistent result if you are updating the database during that process. So we need to create a snapshot that is static essentially, and then take the export and then create a blob from it. That's why you need to create a database in parallel to your working copy. And that obviously continues. Why do you need multiple? That's very important. You need to maintain the same sort of set of previous version in case you recognize the human error too late. Let's say you took a snapshot at midnight today, and we created and the script created a copy in a different region But the human error took place day before. So if you don't have a copy of the day before state in a different region, in case you lost the entire region, you will not be able to recover from the human error. So the combination of human error and a major disaster will result in a copy that is no good for you, really. That's why it's the same number of previous version that you need to maintain in a different region. So let's imagine something happened, God forbid, with West Europe, and we lost the entire data center. So now your end user basically is sitting there not being able to connect to the application. So the admin has to make a decision. Presumably admin gets a call or recognizes, because there is constant monitoring of the connectivity, essentially using perhaps synthetic transactions, that there is no connectivity to this region. He or she has to make a decision about failing over to the redundant copy. So the first step to do is create a copy of the database from the backpack. It's essentially import from the blob. Once it's created, second one, activate an application. It could be a web app on standby, or a virtual image of the application, something that basically makes the application itself live. That includes also, obviously, verifying that the application can connect to the database and is operating normally before you can sort of open the gates and allow the end users to connect to it. And finally, you change the DNS address to the North Europe, and now the next time the end user connects, it gets resolved to your redundant copy of the application, and in turn the application connects to redundant copy of the database. So that's the process. Again, in this process you create a copy of the entire database, or you create a backpack of the entire database in the blob storage. Again, you're responsible for the cleanup, no differences compared to the previous scenario. Now, same charge, prorated day use. So when you create a copy, even temporary copy of the database, you will pay in a daily, prorated daily cost of the database. Same for the database federations, it's coming soon. So what is RTO here? Basically, it's the time it takes to import the database from the blob, time it takes to activate your application and verify that application is operational and healthy, and the DNS change. So in reality, the biggest component of RTO here is the time to import the database, and that unfortunately depends on the size of the database. If you have a big one, it will take hours to import. If you have a small one, or you have a number of small ones, it's much easier because you can, in parallel, create these small imports. And what about the data loss? In this case, the data loss really is your interval of creating these database copies or taking the export of the database. If you do it daily, your data loss, maximum data loss is a day, last day of the updates of the application. If you cannot tolerate daily, you will have to do it much more often. But you will be limited by the time to export your database, because that time depends on the size. And the other observation in this particular solution is that because you are exporting remotely from, let's say, West Europe to North Europe, because of the latency, that export will take longer and to some extent will limit how often you can take those snapshots of the database. So now I wanted to show you a quick demo, basically how it actually looks in reality, but we had, talking about business continuity today, a database, I'm sorry, the internet problem. So let me see if we have it back.
Oh, sorry, it's still not working.
Still not working? Yeah. All right. Well, unfortunately, I need to access the cloud to show the demo, and nothing works. I'm fine with Wi-Fi or whatever, but it doesn't seem to work anyway. Let me just try. Actually, it might work. Let me see. Just a second. Let me try. Oh, okay. Looks like we're working. Okay, good. So let me show this to you. Okay, so what I'm doing is I'm connecting to my subscriptions, Windows Azure subscriptions. And I have several. I will have to go back to, this is the latest portal, but unfortunately I'm going to have to go to the previous version because the import and export capability has not yet been implemented in the new portal. So I'm going to have to go back to the previous portal, unfortunately. But that's fine. It should still be okay. So this is the previous portal, and what I have here, I have. Let's see. Okay. I have several databases. More important ones are this one. It's a database called VentureWorks. It's actually, let's see. Oh, okay. So this is the West Europe. So let's say our home region is West Europe, and I have this database. In North, I actually am going to remove this database for now to make sure that we don't have anything, because I want to show you the whole recovery process. So North Europe now will have nothing. So here's the database, and what I'm going to do is I'm going to create an export from this database to North European blob storage. I will use UI for that. But the recovery process, I will use the script to basically show you both ways of doing this. So let's go to my storage accounts. So I have different storage accounts, but the important one is this one. And I have the North Europe subscription. And first of all, I need to get a key because it uses the certificate-based authentication. So I get a copy of the key. So that is the storage subscription I'm going to use to put my backup of the database into. So to do that, I go to my database in West Europe. It's here. And I'm going to create a backpack in the storage. So remember, I copied my access key, and I'm going to paste it here. Now, I need to specify the blob. I have a little helping script here. This is the blob, and let me just bubble it up. So in this blob, what I specify the URL to my storage account in which I have a container called backups. And I'm going to create a file called AdventureWorks Azure Backpack. That's what I'm going to create. So I'm going to copy this thing. I'm going to go back to my form here. And here I'm going to have to specify the administrative password to my database. So I'm going to put my So as you see, it's export database to storage account. And like I said, it's basically creating a backpack from my West Europe database location to North Europe storage account. I'm going to say finish. Interesting. Let's see what's going on. So one thing that I'd like to recommend, there is this free client called Azure Storage Explorer, very nice tool you may want to install from, download from Windows Azure page. And okay, so I'm going to select my, and it basically allows you to browse your files in your storage containers just like you browse the file system. I suspect network is really slow now. Maybe a lot of people are using it or whatever. Or maybe there's some bandwidth problems. So we'll see. Yeah, it doesn't look like we are in luck. And let me try this again one more time. If not, then I'll just move on. So we have the URL. We have the key. Okay. All right, looks like we have something going on. So what I've done is I've now created a request. This is asynchronous operation. It's not going to come back when it's completed. It comes back immediately. It puts the request in the queue. And now you can go and check the status. Again, I specify the database credentials. And it shows that it failed. So again, you need to retry. And I suspect, again, it's a connectivity issue because, okay, it's connected here. Let me remove this one. This is the previous copy. I was basically testing it, but it actually created a copy. I don't want to retry it, but this is what's going to happen. It's going to create a backpack in this container as a result of this operation. So now we have a redundant copy of your database in a different region. You can count on that backpack in case something happened in West Europe. So if I go back to my my databases, and like I said, in North Europe now, I don't have a database. And let's imagine West Europe failed. Now you have to go through the process of recovering that database in a North Europe region. So instead of using a UI, I can also use a script. Basically, we have a CLI tool that is available for you on the Codeplex. You can download it, and I have a pointer later on in the deck. You can download it, and it's open source, so you can actually look at how we call the RESTful API to the service to import, export the databases. If you wish to, for example, add it to one of your programs, you can use this as an example. Or alternatively, you can simply call that CLI tool in your batch file if you wish to automate it this way. And this is exactly what I'm going to do. So I have that command. It's a little bit long, but what's important here is I'm specifying my North Europe database name. I'm specifying my admin credential, exactly what I did in the UI. I'm specifying the database name that I'm going to create from the backpack. And I'm specifying the storage key. After having done all this, I can run it in the script. Now, it said that it submitted the request, and it essentially is creating the database from the backpack. And if we go back to our database and refresh it, as you can see, it created the database copy here from the backpack. So essentially, now you have a database that is available for your application in a different region. So you can now use that database after you verify that the application is healthy. That's essentially a process. It's pretty straightforward. You put a backpack into the different region, and when necessary, you create an import from it into your database and use that database as a new active database for your application. Now, one thing to say about this import-export service. When you create a backpack, first we create a very small file in the storage to verify that we have the right key to access. And we never charge you for the storage until the process is completed. For example, if something failed in the process of creating the backup, we will not charge you for that. So the entire data set is created first locally and then transported to a different region which you specified in the command. So, and again, this is asynchronous. You can use either direct API, which is something that we call in this little command that I just used, or you can put the command itself into your batch file. It's up to you. Or you can use the UI. Different options you have. Let me go back to the deck. Now, remember in the very beginning I said that data storage is replicated locally and remotely. So one thing that is sort of a bit problematic in the solution I just demonstrated is that latency between the data centers and the time it takes for you to create a backpack of your database remotely. So one option to consider in this case is dependency on built-in geo-replication of the Azure storage itself. In this case, instead of creating the backpack remotely in your backup region, what you will do, you create it locally. But when you create your subscription, you will make sure that your storage account is geo-replicated. It's an option for you. So you turn it on, and what happens when you create a blob locally in West Europe, it immediately gets replicated to North Europe. So you don't have to wait and spend time of creating your own blob in North Europe. It'll be there for you automatically. So you would think this is sort of a no-brainer. You just always do that. You rely on the geo-replication. And yes, you can do that. Clearly, in that case, creating the backpack locally will be much faster because it's a local network. However, there are also some flip side here. So like I said, it's quicker to create a local. RPO is still the export interval, but now because you can sort of create the backpack quicker, potentially you can reduce your the interval when you create those copies. You can take it instead of, for example, daily or weekly, you can take it daily or maybe every so many hours, etc. However, the big downside is that now you are actually dependent upon the failover of the blob itself, and that is controlled by the Azure Ops. The tentative expected RTO here is 24 hours. So essentially, you will not have access to your backpack in Northern Europe until Windows Azure Ops team decides that the data center in Amsterdam is completely lost and we have to fail over to Dublin. And they will take time to investigate what happens and if there is any chance of recovery before they make that call. Because there is a data loss and they will not take any chances until they've exhausted all possibilities, essentially. They will be working hard and they will take up to 24 hours to figure out and make that call. During that time, you essentially will be sitting and your application will be down. So your downtime will be much, much more significant. So that's a trade-off. You can rely on the geo-replication, but you will lose some amount of control. Alternatively, you create your own copy in the remote region, you will have full control. You don't have to wait for anybody's decision to fail over anything for you. You will just basically say, okay, my SLA requires, for example, that my application downtime cannot exceed 4 hours. It doesn't matter if in the 6 hour, 7 hour, the data center in West Europe will be recovered. I cannot wait that long because that is what your SLA requires. So if you have your own copy in North Europe, you can basically take the failover and do it at the time of your own, under your own control, when you basically feel that it is important for you to have your application up and running. So that's a trade-off. Again, a few seconds for your questions, if any, before we move on. All right, just a quick survey. Given what I told you, do you feel that this meets your SLA? And by SLA, I really mean when you put an application into the cloud and you run your business, what is the SLA that you give to your own clients? Number two, maybe okay for now, but down the road will not be sufficient. Or number 3. So let me see how you guys think about it. Number 1, who feels that number 1 is what is acceptable? Okay, good, about 30%. Oops, sorry. How about number 2? Number 3? Oh, it's interesting. So my estimation is about 30% actually okay with number 1, and about 10% in each category, number 2 and 3. Well, let's talk about this. So that's essentially the roadmap conversation I'd like to have. Our estimation is that more and more customer, especially as more sort of business critical applications move to the cloud, they would probably require lower RTO that is possible to achieve given the solutions I've just described. And more importantly, the RTO dependency on the size is what is a concern we have. It's not so much that you take the snapshots or whatever, but the fact that different databases essentially will be able to be less or more open to risk. So how we go about this? So since we have a way to replicate and create copies locally, the direction we are taking is essentially to do the same remotely. Can we allow you to create a database copy remotely, but as it is created, stay in sync until you decide to terminate that relationship? Again, this is all an evolution of the capabilities we already have implemented in the local context. You can do these things in the same region, but you cannot yet do it across regions. Now, we are extending that, and we will support the ability to essentially maintain geo-replicated databases in sync. As you create your geo-redundant copy of the database, it will be essentially, for all practical purposes, a normal database with the same level of local redundancy as in the current situation, in the current implementation. So you will essentially have 6 copies of your database. So we take the capabilities we already have and we extend it to geo. It will be an opt-in. You will have to decide if you want to do it, because clearly it is something that you will have to pay for. It is not included in the base price, although we may basically create a special SKU which will have both copies in it. We will take care of automatic replication and synchronization. You don't have to worry about this. You just basically create a copy and we will take care of the rest. One option we are working on is the RPO enforcement. You will be able to set the level of maximum data loss you can tolerate. For example, if your SLA requires that the data loss cannot exceed, let's say, 30 minutes, you can specify that period in the API or in the UI, depending on which interface you use. And what we will do, we will essentially monitor that period for you. And if, for whatever reason, you have accepted more than 30 minutes of transactions that are not yet replicated, for example, because we've lost connectivity between the data centers, we will stop your application from new transactions activity. The transaction will fail. And that's essentially what you've asked. You basically asked, okay, I don't want to commit more transactions until I know that they're all currently redundant in the different regions, so we will throttle your transaction activity. It's an option. By default, we will not do that. It's only for those applications that are super sensitive to the data loss. And not every application will be tolerable to, let's say, transaction failures. Now, the geosecondaries, we call them geosecondaries, they are read-only, so you can use them, for example, for some additional activities in parallel. You can have sort of a normal application on the primary that does the updates, but you may have, for example, an application that generates reports on the secondary, so you can sort of load balance between the two databases. You can create more than one. If, for example, you are concerned that after losing one of the secondaries you will be exposed, you may have more than one. Now, reality is, in every region we only have 2 data centers today. We are building new data centers regularly, expanding our capacity, but this is not yet available everywhere. And I know that many databases cannot, for example, keep redundant copy outside of certain political boundaries. For example, it may not be allowed by the policy, by the compliance requirements to have a copy, let's say, in the US or in Asia. So in reality, you only have 2 data centers today. But the technology allows you to create multiple geosecondaries if required. The failover process is controlled by the user again. The reason we don't do it automatically is because of the data loss involved. Because this is a synchronous replication, latency is such that we cannot wait for the replication before we return the transaction. It will be too slow. It will be too inefficient. It will impact performance. So what we'll do, we replicate immediately, but we will not wait. And as a result, that will cause some level of data loss if a big disaster takes place. So because of that data loss, we essentially expect you to participate in the failover decision. You will have to basically decide, okay, should I wait? Maybe this data center will recover soon. Or should I just move on and take the data loss and activate my redundant copy of the application elsewhere? That is the application-specific decision, and it depends on the sort of level of tolerance to the data loss. And finally, point-in-time recovery. I quickly say what we're going to do here. Again, remember I said we have backup for every replica on the attached storage. The idea is to essentially expose that backup to you. And instead of requiring you to create backups, essentially just specify the point-in-time recovery. Because we already have backup and those backups incremental, you can just say, hey, I want to go back to 5 o'clock yesterday. Those backups are highly available. We have 3 of them. And when you request the recovery, it creates a parallel copy of the database, and then you can decide whether you want to make it active, or you may want to just dump some data from it, or what have you. And the granularity of that recovery will be essentially any point in time within the retention period. If retention period is 2 weeks, we haven't concluded what that retention will be, but you can specify up to a second. I want the recovery to this point because the backup incremental. All right. So what we talked about is that there is this set of problems, and we already provide the foundation of business continuity and a range of solutions available for each of those problems. There is different level of participation that requires from you. In the case of local failures, it's just a retry logic in the application. In the case of recovery to a point in time, you have to create a copy of the database, maintain multiple of them, or alternatively create a set of backpacks and maintain multiple of those backpacks in the blob storage. And finally, the same, but in a different region for the recovery in a case of geographic disasters. And we will certainly announce as soon as we have the next implementation of the next set of features in the space of business continuity, so stay tuned for those announcements. And I'd like to recommend some of the sessions that might be interesting for you to attend, which, in my opinion, are related to business continuity. With that, let me turn to your questions. Okay, so is the underlying storage technology snapshot based in order to DB being able to be rebuilt in 30 seconds? Okay, so the underlying technology is called logical replication. It's essentially every time we commit a transaction, we immediately set a sort of a logical update to the other database. So essentially, database stays in sync all the time, and therefore there's no chance that the database can have an inconsistent state. And that is the same mechanism will be used in the geo-replication case, which is why I'm saying it's an evolution of the capabilities we already have proven in our existing implementation. We are not introducing anything really new. However, making that same mechanism work across data centers is actually quite a challenge for a number of reasons. But it's a different level of challenge. But the same mechanism that we have today in the local case. Looks like I only have one question on only one text, unless I'm missing it. So any other questions, folks? All right, well then I would really like to thank you for attending. These are additional resources. There is an article that we published a couple of months ago called Business Continuity SQL Azure. Essentially gives you much more details about these different solutions that I just walked you through. There is a sort of a broader article about business continuity in Windows Azure all up, so to speak. It refers to the first one as well, but it also talks about other stateful objects in Windows Azure and a broader set of applications. The article inside SQL Azure will give you all sorts of details about the internals of SQL Azure, how it is implemented, how the local redundancy works, and how the fault tolerance is implemented. And finally, you might want to look at this DEC API, which is essentially the interface to the import-export service, how you can code against it and implement the workflow of recovery that I described. This is just a standard slide, but most importantly, I'd like to ask you to go online and send me feedback, good or bad, about this session. It's very important for me, and I would really appreciate it. So thank you very much for attending, and I hope you will enjoy the rest of the event. That's it. Thank you.